Hello everybody. I came across this really interesting math problem when I was solving a contest, and I thought I'd share it with you guys. So I've assumed that you've read this question, and to be honest with you, when I first saw this question, for a minute I wondered, well, how do you take this equation and answer the question if there are, and show that this equation does not have any real solutions? Well, the best way to solve these problems is to break them down into simpler parts. So right now it looks kind of messy, but we can write this in another form. So when we say that there are there's 2x squared, we can also write that as x squared plus x squared. We'll let 6xy be. We can write 10 as 9 plus 1, and I know it almost looks kind of elementary, but you'll see in a second why I'm doing this. So similarly with 10y squared, you can write that as 9y squared plus y squared, and we can write this as it is. 6y minus 2x equals 0. Now we can group these terms so that this messy equation looks a little bit neater. So we can do x squared plus 6xy plus 9y squared, and you can already probably see what I'm doing here, but I'll write it out anyway. And then we can write this as x squared minus 2x plus 1, and we can write the last bit of the equation as y squared plus 6y plus 9. Okay, so you can probably already tell, but these, so now we've taken this equation and we've written it as the sum of 3 perfect squares. Since these are perfect squares, we can write them as their factors. Yeah, I think I'll just, I'll probably change color. Make it blue. Alright, so now this can be written as x plus 3y squared plus x minus 1 squared. I'll just write that again, plus y plus 3 compound squared. And all this is equal to 0. Well, since the square of any real number is greater or equal to 0, the solution to this equation must satisfy x plus 3y equals 0, x minus y equals 0, and x plus 3 equals 0. And so I'll just write why this must always be true. This is because the square of any real number is greater or equal to 0. Okay, so now that we've established that little fact, we can go ahead and show that there are no real solutions to this question. And you must be wondering why I've drawn a Cartesian coordinate here, and that's because if we were to express, these graphically, so here I'll just draw the lines, draw the graphs. We'll notice something like this. So this will be, actually I'll label them later, but this is pretty accurate actually, and something like that. Now do note that we can solve these algebraically. It's just I think showing it on a graph is a bit more elegant. So let's change our pen color here, and alright. So what we're just trying to show here that this does not have any real solutions, because none of the graphs would ever meet at one point. So these two lines would meet, and I'll probably label them. Oh. So this is x plus 3y equals 0. This is x equals 1, and this is this is y equals -3. So although these two graphs meet here, and these two will eventually meet somewhere over here, and these meet, so these two lines meet here, there will never be a case where all three lines meet at one point, and because they don't, this messy looking function right here does not have any real solutions of the form xy. So once again, guys, this was a little, I guess, this was an okay question, not too hard, but what I wanted to show is that if you know that one little fact, the fact that the square of any real number is greater than or equal to 0, this question becomes really easy, and also if you break it down into smaller parts. So once again, guys, I hope you enjoyed this video, and let me know how I did.